The challenge of scientists in the ionosphere will be the ionosphere is so disturbed and they change very, very fast. We need more ionosphere probe, like a satellite, to be able to constellate, observe the ionosphere, to be able to build a better payload or the transmitter to enhance the quality of the satellite communication.
We need to greatly expand the number of low latency observations that we perform both from the ground as well as in space. So small satellites can play a very important role in this by greatly increasing our capacity and the number of observations that we have in order to understand how the ionosphere varies on short time scales. NCU has a very long history of space science. In fact, we were the first university to be established in Taiwan that performed research in space physics.
The scope of ionosphere research in NCU is to uncover the ionosphere plasma irregularity, which influences positioning, navigation, and communication. We utilize the measurement from Formosa 1 and Formosa 3 and Formosa 7. We built the scintillation model to be able to study how bubble affect the ionosphere propagation. And with us a bundle of the plasma measurement that allow us to construct the plasma electron density for three-dimensionally to develop the model for the EM wave propagation. Currently, the CAPE work with the space industry and aging. They give us the chances to test their material to be able to develop a new satellite probe.
AIP is our first science payload for the satellites with the successful flight heritage. The science payload for the sounding rockets was used to explore E-region plasma irregularities, and AIP on the Formosa 5 satellite was used for space weather monitoring. CIP is the miniaturized models of the AIP. It just weighs around 430 grams and occupies 0.7 U in dimension. This probe will be deployed on a sounding rocket program and several CubeSat programs.
This is the second year of my master's degree, and I'm a member of the Space Payload Laboratory. My role in this work is a firmware engineer. I participate in CIP, Compacted Ionospheric Probe Firmware Debugging.
There are several different ways to study the ionosphere from a satellite platform. In the case of IdeaSat, which is a 3U CubeSat that we're currently developing at NCU, we're using as payload an in-situ instrument called the Compact Ionospheric Probe, or CIP for short, which is an in-situ plasma sensor that allows us to measure the distribution of ionospheric plasma, including its density, its chemical composition, its drift velocity, and its temperature. IdeaSat is also the first small satellite that we're developing here at NCU. This mission is quite unique in the fact that it is being developed in cooperation with our international partners in the International Satellite Program, INSPIRE for short. The INSPIRE consortium was started by us along with the University of Colorado in the United States and the Indian Institute of Space Science and Technology in 2015. The objectives of INSPIRE are to build a small satellite constellation for space science missions, and at the same time to develop a supporting ground network that can be used for tracking and control of these small satellites, as well as to develop a hands-on curriculum. The design, analysis, fabrication, integration, testing, and ultimately operations are all performed by students, both undergraduates and graduates. This gives them the opportunity to really learn both space science and engineering by performing hands-on work on an actual spacecraft mission.
I choose NCU because NCU have a lot of resource for space science analysis. I'm working on the integrating and testing before delivery. I learned a lot during these missions, like the altitude determining and control, and the UHF communications, transmissions, and the receiving.
I chose NCU for working in space because I have started at NCU since college. All the teachers are good examples for us to learn. They allow you to try all the things you want to try.
NCU is the only place that can allow our students can learn the space science and technology from the ground up and conduct the meaningful science missions.
I'm very grateful to be able to work with my colleagues, our international partners, as well as our students who have been very instrumental and inspirational. Together we work to build our spaceflight capacity and also to apply this new expertise to understanding the ionosphere and the upper atmosphere.
I feel very, very excited when I work over the NCU because Taiwan is right under the equatorial ionization zone. Also, we have lots of earthquake and typhoon. Taiwan also have a very long-term ionosphere observation, also with satellite observation, which have a lot of database. This is the best place of the world to uncover all the ionosphere secrets.